Bismillahirrahmanirrahim. Law of conservation of momentum. Before understanding this law of conservation of momentum, you must be clear about it that the momentum of a system depends upon the mass and velocity of that system. But here the question arises that what is a system? So let us define that what is a system. The system is the group of bodies. There may be two or more than two bodies within a group. So system is the group of bodies within certain boundaries. Like here I have shown you the group of two bodies within the certain boundaries. So this is called a system of these two bodies. Now we have to understand that what is an isolated system. Now as the word isolated itself suggesting you something, that there may be some isolated system. So here we are talking about the group of interacting bodies within a certain boundaries on which no external force is acting. Like if we are talking about this group of two bodies within the certain boundaries, no external force is applying on these two bodies. These two bodies are interacting with each other. So this is called an isolated system. So remember, there must be a system and there must be an isolated system for the application of the law of conservation of momentum, as I told you. And the momentum of the system depends upon the mass and velocity of that system. The law of conservation of momentum. This law states that the momentum of an isolated system of two or more than two interacting bodies remains constant. We have to understand this with the help of this example. Now here I have taken an isolated system of an air-filled balloon. There is air inside the balloon. Now these are two bodies. One is air and other is balloon. These are two bodies which are making this system. Initially, the air is not allowed to escape from the balloon. So initially, the system is at rest. When the system is at rest, it means its momentum is zero. Consider this, because the momentum is the product of mass and velocity. When the velocity is zero, velocity multiplied by zero, velocity multiplied by mass gives you zero answer. Now, let us consider the second diagram. In the second diagram, when air is allowed to escape from the balloon, air is moving towards right with certain velocity. Now, this momentum can be calculated by multiplying the mass of air and the velocity of air towards right. That momentum can be calculated. Now, to conserve this momentum of air towards right, the balloon will move towards left with certain velocity. That momentum can also be calculated by multiplying the mass which is moving towards left with the velocity with which it is moving towards left. Okay. So, another very important thing which you have to understand here, if you are taking the momentum of air towards right as positive, then you will have to take the momentum of the balloon which is moving towards left as negative. So here we can say that this is positive side which is moving towards right, positive momentum, and this is negative momentum. When you will add up these two momentum, you will see that the resultant momentum will be zero. So initially I told you that before the escaping of air, the momentum was zero. When the system was at rest, the momentum was zero. Then after this, you will see that while adding the momentum of air towards right, which is positive, and the momentum of the balloon, which is towards left, which is negative. So by adding two, again you will get the result zero, which proves the law of conservation of momentum. This can also be proved with certain other examples. To watch the other examples, you can see my other videos. So you can also press the bell icon so that you may be informed about the other videos related to the same topic.